So this chapter is going to be called Exponential Functions, and we've actually been talking about this a lot in homeroom. So in homeroom we've been talking about exponential functions and the equation y equals ab to the x. When we're looking at it today though, we are just going to be using y equals b to the x. We'll talk about that a business later. So we're focusing on this equation, y equals b to the x. Now if we have an exponential function, so notice by the way, I need to point this out, that x value is in the exponent. Oops, didn't mean that. The x value is in the exponent. So b is our base and x is in the exponent. So we have two common graphs when we're looking at this. We have one graph that's called our growth function, and basically what happens is it crosses here at 1, and then on the right hand side it goes up, and it goes up fast and tall. Okay, on the left hand side it's going to come down gradually, and it's going to keep on coming down gradually, and the idea is it gets really close to the x-axis, but it never actually touches the x-axis. It just keeps getting closer and closer. This is called an exponential growth, because as we look at a function, we're always looking from left to right. So as we say it grows, it's because it grows on the right. It's going up on the right. Now a decay function, so the other picture we're looking at, still crosses at the 1. But then what happens is the graph pretty much flips. It's still going up, but it's going up on the left-hand side. And then on the right-hand side, it's going to go down gradually and gradually towards the x-axis, but never actually going to reach that. This is called a decay, because as you look at it from left to right, it's going to get small really fast, and then it's going to level off and get smaller and smaller and smaller here. And so that's a decay. So as you go to the right, it's getting smaller. Alright, so this is actually something we're going to do in class. So next page. So to begin with, we're going to start graphing the 1/2 x. So to graph it, I'm just going to set up a table. I'm going to plug in x values, -3, -2, -1, 0, 1, 2, and 3. And then I'm going to plug in y values, or not plug in y values, I'm going to find the y values for when I have 1/2 to the x. For example, if I have 1/2 to the 0, anything to the 0 power is just 1. So when x is 0, y is 1. I have my point right here. Alright, then let's try 1. If I plug in, I've got 1/2 to the 1. That's just 1/2. So let's see here if I can find 1/2. There we go. And 1/2 squared, so remember I square top and bottom separately, I get 1/4. And 1/2 cubed, that's going to be 1 cubed is 1, 2 cubed is 8. So I get 1/8. It gets smaller and smaller. So here I have where it's getting really close to the x-axis. It's going to get closer and closer. It's never actually going to pass it though, because if you think about it, the x-axis means that the y value is 0. And there's nothing I can take 1/2 times itself so many times that I actually do get 0. I get really close to 0, but I don't actually get 0. Now what about this -1? In your chapter it gives you a video reminding you how to work with negative exponents. So if you don't remember, you need to go back in the chapter and watch that video. But basically what's happening is I have 1/2 to the -1. The negative flips over that fraction, so now I've got 2 to the 1, and that's just 2. And then I plug in -2. So the negative exponent flips over the fraction, so we have 2. Now the exponent's positive, we get 4. And then we take our base and we use an exponent of -3, flip that over, so we get 2 to the 3rd power gives me 8. And so now the graph, as we connect it, you can see it's going up pretty quickly. It's going to keep on going up quicker and quicker, and so this is the graph. Now let's start answering some questions on this graph. So describe what happens to y as x gets bigger and bigger. So when we're saying that, we're following the x-axis this way. So we're following the graph from left to right. That's what this means. As x gets bigger and bigger, from left to right, what's happening to our graph? So if I want to describe what's happening, I'm thinking, you know what, it's getting smaller, right? It's going down really fast, and then all of a sudden it slows down, and it's still getting smaller and smaller, but it's, you know, it's not going below the line. It looks like it's just hugging it. So describe what happens. Okay, we did that. Let's go to B. Does the graph of d of x have an x-intercept? Well, an x-intercept means that it has to get to the x-axis. And that means that I would have to get 0 in here, and I don't think I can get 0, so I'm going to say no. And think about it. If you take a number and you cut it in half, well, now you have all of this, right? And then you take that and you cut it in half, now you have all of this. And you take that and cut it in half, now you have all of this. And you take that and cut it in half, and now you have all... There's no way I'm going to get nothing left, right? I'm always going to have something there. So does the graph have an x-intercept? I'm going to say no on that one. So C, when x is very large, so that means I'm looking way over here, the graph of d of x approaches the x-axis. We agree with that, right? It gets getting closer and closer to the x-axis. In this situation, the x-axis is called an asymptote. This is a very important word for you. Since you're taking notes, you should be writing down asymptote right now. Okay, so the idea of asymptote is that it's a line that a graph gets really, really close to, really close to, but it never actually goes past it. It just hugs it and hugs it and hugs it and hugs it. Okay? So that would be a horizontal. The x-axis is our horizontal asymptote because you can see right here that it hugs it horizontally. So the question is, does d of x have a vertical asymptote? Is there a line going straight up and down that this hugs? Now think about that. This can keep on going higher and higher. I can plug in -3 and get another point, and plug in -4 and get another point, and plug in -5 and get another point. And so if you're going to have an asymptote, basically you're saying it can't go any farther to left, meaning you can't have any of these numbers to plug in. But I can plug in any of these numbers. So does it have a vertical asymptote? No, it does not have a vertical asymptote. And then D says, which cases for y equals b to the x have asymptotes? From what I can tell, looking at any of the pictures and looking at this graph, it's going to have a horizontal asymptote. Horizontal asymptote for x equals 0, or sorry, no, y equals 0, or the x-axis.